Greetings, friends. Randall and Nagy here again, continuing our investigation into the built-in features of Python's built-in modules. And before we take another bite out of that topic, we should note that we went ahead and extracted the mkeval file and put it up on GitHub so as to allow other platforms that don't use f-strings, for example, Python 3.5, to participate in the evaluation, sharing, and differentiation process. Of course, the reason why we did this was I had a virtual machine that had Python 3.5 on it, and I simply wanted to capture and share that delta with you, and you can find both the Python 3.5 Linux evaluation file as well as the new makeevalfile.py up on the built-in report project on GitHub. Now, we threatened to review some of these features from our previous video, and today we're going to jump right in by simply reviewing everything we talked about in the last video, starting, of course, with the print and ending with the eval. I think we'll have some surprises for you. But by way of review, let's go ahead and take a look on the help print. And remember that while we don't have to use the default parameters, there are several included in the print built-in function. And from including separators between our values, whenever there's more than one value to be printed, in this case a space, to creating a different line ending, in this case a new line, to even printing our values into a file, the default being the standard output, so as to keep things peppy by either flushing or not flushing our results to the file handle or the file system output. Print offers us many opportunities which we should make sure we're comfortable with, because we're going to take a look at something that might make your eyes cross here, a simple list comprehension where we're going to add a filtering capability to our well-tried and true dir, or directory listing of an instance of integer. Filtering out anything that came from the dir list of strings, which are member functions, we decided to simply omit anything where the 0th position of that string had an underscore. And rather than using a single space as a separator, we decided to put a new line between each and every one of the items we're going to print from that filtering list comprehension. A lot going on here. Let me cross your eyes a bit. And if you're not familiar with list comprehensions, go ahead and pop over to Udemy and take one of my more advanced training opportunities, because we're straddling the intermediate and advanced topics here as we review as integer ratio all the way through 2 bytes, or the most common members of the integer and related Boolean class. So you may recall from the last video we talked about how Boolean does indeed share the same signature with integer, and you might ask yourself, why do we even bother? Couldn't we have simply come up with a different Boolean class? And the answer is yes. But here's the reason why the Python masters didn't do so, is because if you take a look at bit length, you'll see that whenever we have a Boolean created as we saw, if it's non-zero, it'll come down to true, and integer shares the same feature set. But as we create integers from larger numbers in Booleans, anything non-zero in the Boolean class will be true, and any 0 will be false. So the conversion takes place during the Boolean construction. But when we're using integers, of course, our bits can get larger and larger and larger, because unlike Boolean, integer is supposed to represent more than a 0 or a 1 or a false or a true evaluation. Another interesting thing about integer is as we begin to look at taking things to and from bytes. And by bytes, of course, we mean octets, or 2 to the 8, in which we can specify using 2 bytes how many bytes we want, as well as whether we're big or Motorola hex, or the little or Microsoft Classic or Intel hexadecimal representations. And without going into the historical cases why one processor type was chosen over another more rational one, we should note that most of the world today works on Intel rather than Motorola. So we see the reversal as we see here. But using the exact same arguments, in this case, when we're using from bytes to take our output, as well as to make sure to specify whether we're signed or big or little capability, we can make things appear either as they should be originally, or perhaps to switch things around and make the numbers change their meaning altogether. So because whether we're a little or a big endian does indeed matter, and when we take a look at taking the integer 1, for example, over to bytes, we can see that the little end is printed in a binary string first, but when we go from bytes using the little ended to the big ended, we move up a magnitude, putting the 1 in the greatest position, making it an F or 255 for an integral value. Conjugate is another interesting concept that, from my point of view, is simply there for supporting libraries that would do conjugation. In this case, for example, if we imported math and simply created an integer from the pi positive, we'd see that we, of course, got a conjugate of 3, which might be a little unexpected, but if we took a negative, we get our negative 3, which is simply expressing our numerator, which we'll be talking about later on, as a conjugate, once again, in my mind, for support of libraries, which might need to create more complex integer or integral types. Another similar concept is using the as integer ratio, which will return two values or a pair of integers, which will express a numerator as well as a denominator. If we had a more complex number support, for example, we would see that if we were to use an integer of 7, we'd get a positive 7 with a base of 1 or denominator of 1. Negative 7 would do the same thing as we just saw with the conjugate, as well as with hexadecimal numbers, as we see here, noting that our hexadecimal values can be signed as well as unsigned, and Python will, of course, represent each with their proper numerator as well as denominator, expresses a ratio. As you may expect, in addition to having simple functions, the integer class has some read-only properties, in this case, allowing us another way to access our positive or negative numerator as well as denominator. And not to forget that when we use pi, we see pretty much the same capabilities, in this case, assigning a real and an imaginary part, once again, that we can't really change, but is assigned to us and available for us to reuse, much as Boolean reused similar values, imposing different constraints. So integer is really a nice base class if you want to do a lot of things. For example, create your own Boolean type, where you can have a Boolean value of 255 come to 1, or a negative Boolean value still come up as non-zero, or in this case true. And we pretty much covered everything we needed to know for managing both the built-in as well as any custom integral types we're likely to come up with. Before we move on, I wanted to cover one of the most amazing built-ins that will allow us to shed some light on how Python operates. Of course, I'm talking about vars, the vars built-in function, which will allow us to see the difference between dynamically assigned or instance variables, as we see assigned underneath our double underscore or dunder init, as opposed to class variables, as we see as we assign A and B directly under our class. The interesting thing here is that whenever we assign a value to a dynamic instance of our class, using the self as we see here, we are in effect putting together a dictionary which will create tag value pairs based upon a stringified key value. In this case, no C is being turned into a string, and D as well. And if we call it underdict without any parameters, we will return a dictionary for everything that's in that class or has been assigned to the instance of self. Note that we're missing our class or static members, which can, of course, be accessed statically. In other words, z.a and z.b. But if you don't want to use a underdict all the time, we can use the built-in function vars to create an instance of z. Of course, do much the same thing as we see with calling the underdict. We should take a moment to note that when we haven't assigned any values to an instance, for example, when using our init capability, that until we do assign some values, the underdict won't have anything for our vars to see. That would also be a good time to note that, for example, if we were to create a list and take a look at the vars, we're going to get a problem because there is no dictionary associated with vars or any other of the collection types, as you might expect, which would include a set, as well as an instance of Python's dict or dictionary type, as we see here. So the reason why we decided to choose to show you how to use vars or vars was because it's very handy to understand an alternative way that we can use type to create an object. This is incredibly advanced. I doubt very seriously anybody's going to need to use it, and that's why perhaps people never cover it. But I wanted to make sure that we had a chance to understand how we can use the built-in type functions to create an instance of a class, in this case, Z class, by providing args and kwargs as optional parameters, in addition to the requisite name of the class that we have to create. In this case, it's easy to see how we indeed can use Z class normally, simply by giving us our keyword arg, setting times equal to 3000, in which, of course, we would see what we would expect. In other words, things would be initialized and self.times would be 1000, even though we're ignoring the keyword arguments. However, if we were to use type to create an instance of this class, we are going to set up a separate dictionary of values and completely omit the initialization by either the dunder init or the dunder new static method. Incredibly advanced. Just wanted to make sure people are aware of using type because we can find many security as well as big data use cases for using type initialization that, to tell you the truth, very few of us would need to know about in the normal operations of the Python programming language. This is why I say Python is very easy to learn. It's very difficult to master. And for more information on how to use new, as well as init, as well as alternate class creation strategies, please take a look at one of my advanced training opportunities available on Udemy, as well as other educational content providers. So part of your personal to-do list, I would take it to task to go over to our built-in report website, download and open BLT type ex.py, run it, tweak it, and see how it works for your machine. And you might also want to try the following at home so that we can check off copyright credits and license, which you can look at as being read-only properties in the global Python built-in scope, and by way of enjoyment as well as edification, type in help this to see some idea of what this or Python is all about. And an interesting side note would be to take a moment to input anti-gravity. Once again, a bit of an Easter egg here that you might want to share and enjoy, as well as use to impress your fellow Pythoneers. So once you've completed the homework, you see we have a very healthy set of operations that we have covered, almost 20%, but there's a lot more to come, and certainly some more PyQuesting questions and answers we might enjoy. For example, after completing this level, we should be able to understand that when we use the integer, as we see here in KA 1061, that we would either get an exception, a negative false, true 255, or negative 255. Should be easy enough to answer. As should KA 2036, an intermediate question, where we should probably be able to tell people what to expect when we use vals, that we would use vals to either 1, create object dictionaries, 2, manage collection types, 3, access Dunderdict values, 4, manage string values, or 5, manage integral values. Another intermediate question, KA 2037, will simply ask a similar question, only rather than using integer, we're going to use bool. And we should be able to tell people that when we do so, we would either see an exception, a negative false, true 255, or negative 255. KA 2038 is one of those eye-crossing list comprehensions, but by now we should be able to tell people that the above list comprehension would either 1, produce a range exception, or 2, show all public members, 3, show an empty list, 4, show all private operations, or 5, none of the above. And finally, we have a very advanced question in the form of KA 3036, which would allow us to respond to the query of, we can use the built-in type function to either 1, change existing members, 2, create objects, 3, safely remove presents, 4, determine instance type, or 5, 2 of the above. Well, I hope you have enjoyed our BLT report video number 2, and stay tuned because next will obviously be some more interesting PyQuest review as we go into the BLT report for our 3rd installation of our PyQuesting Pythoneering operations. This is Randall Nagy signing off, and I am indeed looking forward to seeing you in the professional software development world.